You're playing Pokemon, everything is going well, then you get Ionoed, miss a piece, and proceed to lose shortly after. You've been there, right? Everyone has. But maybe you win that game if you correctly determine whether or not to shuffle the deck after the Iono. For example, you're playing Gholdengo, you just took your second prize of the game against Gardevoir, and they Ionoed you. You had a superior energy retrieval in your 5 card hand before the Iono, and you have another 3 superiors in the other 20 cards of your deck. After drawing your new hand, you have the option to draw right away with your Gholdengo, or you can shuffle the deck first with Genesec's ability. Should you shuffle, or should you not? That's what I'll be answering in this video, when to shuffle your deck after an Iono. Given this example, you can try to figure it out. If you shuffle the deck, there will be 4 superiors in a 25 card deck, and if you don't shuffle, then there will effectively be 3 superiors in a 20 card deck. That's 4 out of 25 versus 3 out of 20, but that's not easy to compare, especially in game when you only have 15 seconds per action. Here watching this video, you can pull out a calculator and figure it out. If you shuffle, the deck becomes 16% superiors, and if you don't shuffle, your deck stays 15% superiors. So in this scenario, you should shuffle the deck before you draw. However, you shouldn't be pulling out a calculator in the middle of a game. The goal of this video is to outline a fast and easy method of determining when to shuffle the deck after Iono, a method that can be performed in-game without causing any pace of play issues. Iono has unique properties in the Pokemon TCG. When an Iono is played, it effectively splits the deck into 2 portions. The bottom portion is your old hand, now randomized, and the top portion is the rest of the deck, unshuffled from the effects of the Iono. The cards in the bottom portion of the deck cannot be drawn until you have drawn the entire top portion of the deck. So in determining the probability of hitting an out, we are only concerned with the top portion of the deck. Alternatively, if you choose to shuffle the deck before drawing, the top and bottom portions are randomized together and the odds of hitting an out change. So, how can we determine when it is better to shuffle after an Iono or not quickly in game? First, you need to have prize checked. You need to know what you have access to when making a plan. Then, when you are Ionoed, before you shuffle your hand and offer it to your opponent, you need to take account of the amount of outs you have in hand and the number of cards you have in hand. Then, after shuffling your hand and offering it to your opponent, you can pick up your deck and draw a new hand. Before placing your deck back onto your old hand, count the deck. This is public knowledge in the TCG, and because this is all happening during your opponent's turn, you shouldn't be worried about pace of play for this. After putting your deck back, you need to look at your hand and determine how many outs there are in the top portion of the deck. This is simply the amount of outs in the list, minus the amount of outs prized, minus the amount of outs sent to the bottom, minus the amount of outs used already, minus the amount of outs already in hand. This sounds complicated, but it's not. Just count the amount of superiors that you have access to and subtract the amount you have sent to the bottom. Then you need to do the math. We'll be comparing the number of cards in the top portion of the deck to this product. The amount of cards sent to the bottom times the number of outs in the top portion divided by the number of outs sent to the bottom. If the amount of cards in the top portion of the deck is greater than this product, then you should shuffle the deck. If the amount of cards in the top portion of the deck is less than the product, then it is better not to shuffle. When these values are the same, you have the same odds either way. For example, here's the scenario. 1 out in a 6 card hand is sent to the bottom, and there are 3 outs in the 20 card top portion of the deck. Should you shuffle? We'll multiply the amount of cards sent to the bottom, 6, by the number of outs in the top portion of the deck, 3. Then we need to divide this by the amount of outs sent to the bottom, 1. This leaves us with 6 times 3 divided by 1, which is 18. Here, the number of cards in the top portion of the deck, 20, is greater than this product, so we should shuffle before drawing. And if we had a 7 card hand? We'll need to do the same math again. We'll multiply the amount of cards sent to the bottom, 7, by the number of outs in the top portion of the deck, 3. Then we need to divide this by the amount of outs sent to the bottom, 1. This leaves us with 7 times 3 divided by 1, which is 21. This time, the number of cards in the top portion of the deck, 20, is less than this product, so we'd have better odds if we didn't shuffle. Let's try this in game. I've just been Ionoed, so let's check the hand. One superior and a 6-card hand. I'll shuffle up my hand and offer it to my opponent, then draw myself a new hand. Before putting my deck down, I'll count it. 23 cards. At the start of the game, I prize checked, so I know that I don't have any superiors prized. After looking at my new hand, I can determine that there are 3 superiors in the top portion of my deck because I just sent a single copy to the bottom, and there's none prized, none in hand, and none in the discard. Now I can do the math. 6 cards were sent to the bottom, times 3 outs in the top portion, divided by 1 out in the bottom portion, 18. The amount of cards in the top portion, 23, is greater than this product, so I should shuffle before I draw. To determine this formula, I did some MATLAB code. Here's the fruit of that labor. This graph shows the concepts that I've been talking about so far. You can't bring this to a tournament or anything, but it is a good reference. The x-axis shows the amount of cards in the top portion of the deck, and the y-axis shows the amount of cards in the bottom portion of the deck. First, you find the point that represents your board state. Then you identify the line that represents that board state. Lastly, you see where your point landed. If it is above the line, then you shouldn't shuffle, and if it is below the line, then it is better to shuffle. There are a few things to keep in mind about this method. First, it doesn't account for thinning the deck with your searches, although this does improve your odds. If we do the math and determine that we shouldn't shuffle, but the numbers we compare are really close, like the 20 and 18 we compared earlier, then it is likely better to shuffle if we are able to thin the deck with that search. On the graph, this effectively rotates the lines slightly counterclockwise. Second, if you happen to top deck a superior, then your math changes. If you have a lot of time during your opponent's turn, then you can cover for this possibility by doing the math for a deck that is 1 card smaller with 1 less out in it, but this isn't really worth it. The majority of the time, if you start your turn by top decking a superior, then it will be better to shuffle. I've used this method for about 4 months now, and I've gotten pretty quick with it. Knowing when to shuffle after an Iono is a great confidence booster. Here's a nice graphic again if you want to screenshot it. Thanks for watching, and go follow me on Twitter.